Hello, so in this video we're going to be looking at differentiating the exponential function, that is e to the power of x. Now, a unique property of the exponential function is that when you differentiate it, you just get it back. So if you have y equal e to the x, when you differentiate it, you get dy by dx equals e to the x. So that's a very special property and different from all the differentiation you've done so far. Now just note that e to the x is never 0, and when x equals 0, e to the x equals 1. And just quickly so you remember what it looks like, it sort of comes through like this, and then it goes up like that, and then it gets faster and faster and faster, and at this point here is 1. So that point there was 1. Okay, so before we start differentiating e to the x or functions with e to the x in them, I just want to quickly remind you of the chain rule. Now we use the chain rule when we're differentiating a function of a function. And in this case, it would be like e to the 3x, something like that. The product rule, when you have two functions multiplied together, so that's like x squared times e to the x. And the quotient rule, which we're not actually going to do an example of here, the quotient rule you use when you have one thing divided by another. So you have e to the x over x. And if you're not sure about any of those, please go and look at the videos I have on each of them. Thank you. Okay, so the first one, y equals e to the 3x. And this is like a function of a function. Okay, so the first thing we did, as we did before, is sort of which bit is giving us trouble. It's this 3x, because if it was just y equals e to the x, we would know how to differentiate it. So we make that equal to our u, and then y will become e to the u because this 3x has become u. We then work out all the bits, so we need dy by du. So we look at this one. This is the one with y and u's in. And when you differentiate e to the u, you'll just get e to the u back, because that's this special property of the exponential function. And then if we differentiate du by dx, this is this one here, we'll get 3, because if you've got a function which is a constant or a number times x, when you differentiate it, you just get the number. Now we can put it together using the chain rule, which I've got up here for you. So dy by du, just pluck out all the bits, is this thing, and du by dx is this thing. And so we get 3e to the u. Now you haven't finished, you have to remember to substitute back for u. So what was u? U was 3x. So this becomes dy by dx equals 3e to the 3x. So the fast way of doing this, and don't listen if it's already too complicated, is you sort of just pretend that this is e to the x. So if it was e to the x, what would you get? Dy by dx would be e to the x. So you'd write down that. So you just have e to the 3x. But you say, well, actually, I was in denial, really. This wasn't x, it was 3x. And when I differentiate 3x, I get 3. So you can do it without all the substitution. You're still using the chain rule, but you can do it without all the substitution. If you don't find that very clear, go through methodically. Okay, so here we have the product rule. That means one thing times another thing. And the product rule says you leave one alone, differentiate the other, leave the other alone, differentiate the first one. So just label each bit. So your u is the first bit of your product, is x squared, and the v is the second. Then you work out the things. So you've got du by dx. So if it's x squared, you multiply by the power. And you take 1 from the power, 2, take away 1 is going to give you 1, so it's like a little 1 in there. And then e to the x is this special function, just gives you e to the x. And now you just put all the bits in here. So what was u? So u was x squared. dv by dx is e to the x. Then v was e to the x. And then du by dx is 2x. And so, you can just leave it like that if you want, but I have just tidied it up a little bit. Anyway, I hope that's helpful. Basically, you just need to remember that when you differentiate e to the x, you will get back e to the x. Okay, thank you.